So, you guys must have surely played the game Angry Birds, right? Will you believe if I told you that this game is based on a quadratic curve? Now, let us assume that you are a game developer and you want to design a game based on the concept of a bow and arrow, such that when the arrow is drawn with certain amount of force and shot at a particular angle will hit the target. Okay, this game must be realistic. Only then players will be attracted to the game. It is important that the arrow that comes from the bow must follow a trajectory motion because every object that is thrown in reality will follow a quadratic curve. Not just that, this trajectory path will also make the game more challenging. As a game developer, to set a trajectory motion for that arrow, you might have to use code in programming languages like C Sharp. Here, the target is not on a flat surface, but on a slope which is inclined at an angle. So the score the player will get for shooting at a particular point must be coded by the programmer for every level. This target point is nothing but the intersection of the quadratic curve traced by the arrow and the straight line on the slope. This point can be obtained by solving system of linear and quadratic equation. So you would have now understood how important it is for a game developer to know how to solve linear and quadratic equations. Welcome to Fun Maths Academy. Today we are going to learn how to solve simultaneous linear and quadratic equations. We know that a linear equation is made of variables like x and y and a constant. The highest power of these variables will be 1. Not just that, when you plot that equation in a graph, you get a straight line. On the other hand, a quadratic equation has at least one variable with the highest power, that is 2. When we plot a quadratic equation with highest power 2 on a graph, we get a parabola. The solution we get when we solve these equations will be x-intercept. When we try to solve a system of equations with either two linear equations or one linear equation and one quadratic equation, the solution of such a system will be the intersection point of the two lines or curve and a line respectively. Just like how for a system of linear equations we can have one solution, no solution, or infinite number of solutions, in the same way, for a system of linear and quadratic equations, we can have two solutions, one solution, or no solution for those equations. Now, there are two ways to solve a system of linear and quadratic equation. Number 1 is algebraic method and number 2 is graphical method. For simultaneous linear equations, we can use substitution method to solve them, right? In the same way, we can use substitution method to solve simultaneous linear and quadratic equation. So let us now see how to solve simultaneous equations using substitution method. In a simultaneous equation, we will have two equations. One, a linear equation of the form y is equal to m into x plus k, and the other a quadratic equation of the form y equal to ax squared plus bx plus c. First, let us rearrange the linear equation to write it in the form x equal to or y equal to. Then we shall substitute this value in the quadratic equation. And we will then get a quadratic equation with only one variable, which is either x or y. Then we should simplify this quadratic equation and substitute it back into the linear equation. When all these steps are done, we will get the solution as two coordinate points. These 2 points are the places where the curve and the line meets. Remember the game we talked about in the beginning, the game of bow and arrow? These two coordinate points will denote the point of the arrow on the bow, and the other point will be the point where the arrow meets the target. Okay, now when we solve a quadratic equation, we will either get two solutions or one solution or no solution. right? In the same way, when we solve quadratic equation of the simultaneous equation, we get two solutions. And these two solutions denote the points where the parabola and the line meets. In case we get one solution, it means that the parabola and the line meets only at one point. Likewise, if we get no solution, then it means that the parabola and the line doesn't intersect at all. To figure out what kind of solution we will get, we use the concept of discriminant here. Discriminant is found using the formula b squared minus 4ac. Once we substitute the values of a, b and c of the quadratic equation into this formula, if we get b square minus 4ac to be positive, that is greater than 0, then we will get two solutions. If we get b square minus 4ac to be equal to 0, then we will get only one solution. If we get b squared minus 4ac to be less than 0, that is negative, then we will get no real solutions. Here, the discriminant is not just used to figure out how many solutions we will get, but it is also used to decide on which method we can use to solve it. We already know there are three methods to solve a quadratic equation. 1. Factorization method, 2. Quadratic formula method, and 3. Completing the square method. Factorization method is pretty easy, but it cannot be used to solve any quadratic equation. Rather, the other two methods can be used to solve any kind of quadratic equation. Now, to figure out whether we can use factorization method to solve this equation or not, we have to find the discriminant. If the discriminant ends up to be a perfect square, then factorization method can be used here. Okay then, let us now see how to solve this simultaneous equation. Here, y is equal to 6x plus 20 is a linear equation and y is equal to x squared plus 4x plus 5 is a quadratic equation. First, we have to rearrange the linear equation and write it in terms of variables x or y. Since this equation is already in terms of x, we just have to substitute this value of y in the quadratic equation in the place of y. That is, we get 6x plus 20 is equal to x squared plus 4x plus 5. Since this new equation is in terms of only one variable, we will have to add or subtract on both sides appropriately. When you subtract by 6x on both sides, 6x will get cancelled in the left hand side. By subtracting 6x from 4x, we will get minus 2x on the right hand side. To remove the constant 20 from the left hand side, we are going to subtract by 20 on both sides. And so we will get 20 minus 20 is equal to 0 on the left hand side. On the right hand side we will get 5 minus 20 which is equal to minus 15. And so we finally got the quadratic equation to be x squared minus 2x minus 15 is equal to 0. Now we have combined the two given equations and we got a quadratic equation. On solving this equation, we will get two values of x. But that answer is not complete. All that is left for us to do is substitute these two values of x in the linear equations and then we will get two values for y. Now let us first solve x squared minus 2x minus 15 is equal to 0. Like I already said, we can find discriminant and decide which method we can use to solve this. So in this case, we have a is equal to 1, b is equal to minus 2 and c is equal to minus 15. When substituted in the formula, we get minus 2 the whole square minus 4 into 1 into minus 15. Minus 2 the whole square will be equal to 4. And also minus 4 multiplied by 1 multiplied by minus 15 will be equal to 60. Now, when you add them all together, we get 4 plus 60 is equal to 64. Since 64 is a perfect square, we can now use the easiest method, that is the factorization method, to solve this problem. On multiplying coefficient of x square and constant, we get minus 15, right? Let us find the factor pairs of minus 15, which will be 1 into minus 15, minus 1 into 15, 3 into minus 5 and minus 3 into 5. Now of these pairs, which one when added together will be equal to the coefficient of x, that is minus 2? Let us find out. When 1 and minus 15 are added, we get minus 14. When minus 1 and 15 are added, we get 14. When 3 and minus 5 are added, we get minus 2, which is the coefficient of x, right? So then, this is our factor pair. In the place of minus 2x, let us now substitute 3x minus 5x. Then we shall pull out the common terms from the first two terms and then pull out the common terms from the last two terms. As x is the only term common in the first two terms, let us pull it out and so we will get x into x plus 3. Then the common term of the last two terms is minus 5. So when we pull minus 5 out, we get minus 5 into x plus 3. One thing we need to make sure is that the factors in the braces must be the same. So on pulling the common factor out, we get x plus 3 into x minus 5, which is equal to 0. Since we get that the product of these two factors is equal to 0, we will get x plus 3 is equal to 0 and x minus 5 is equal to 0. From this, we get values for x as x is equal to minus 3 and x is equal to 5. Only when we know the values of y for these values of x, we can find out the two coordinate points where the parabola and the line meets. So for that, we should substitute these values of x in the linear equation and find corresponding values of y. These values of x can also be substituted in the quadratic equation to find values of y. No problem at all. The reason why we chose linear equation in this case is that quadratic equation has more number of terms and also the power of the equation is high. So to make our work easier, we are going to substitute in the linear equation. When we substitute x is equal to 5 in the linear equation, y is equal to 6x plus 20, we get y is equal to 6 into 5 plus 20. We then get 6 into 5 is equal to 30 and so y will be equal to 30 plus 20, which is equal to 50. When we substitute x is equal to minus 3 and y is equal to 6x plus 20, we get y is equal to 6 into minus 3 plus 20. We then get 6 into minus 3 is equal to minus 18 and so y will be equal to minus 18 plus 20, which is equal to 2. So now we get the intersection points to be 5, 50 and minus 3, 2. Likewise, if we have rearranged the linear equation in terms of y and substituted in the quadratic equation, then we would have got two solutions for y. And then when these values of y were substituted in the linear equation again, we would have got values for x. And even then, the solution would have been the same as 5, 50 and minus 3, 2. You can do it either ways. Now, next, we shall see how to solve a system of linear and a quadratic equation using graphical method. This method is very simple. We just have to plot these two equations as a curve and a line and find the points of intersection, which will be the solution of this system of equations. You can either plot this graph manually or you can plot it using a graphical calculator. Desmos is a web-based graphical calculator which serves this purpose. Its link is given in the description box. Do check it out. To plot this graph manually, first we have to rearrange this equation and write it in terms of x. Then for different values of x, we have to find values of y and then write it in a table. Now you may wonder how to choose values of x, right? For that, let us start from the center of the parabola that represents the quadratic equation. The central x value of the parabola will be its line of symmetry. Line of symmetry formula is what we get when we delete the formula of discriminant from the quadratic formula. Keeping this as the center value and assuming values for x on both sides, we can find values of x. we can find values of y by substituting x in linear equation and in the quadratic equation. On substituting, we will get a parabola and a line. From this graph, we will get the intersection points. For better understanding, let us solve this simultaneous equation. Y is equal to 2x minus 6 and y is equal to x squared minus 4x plus 3 using graphical method. First, we should choose values for x. For that, we need to find the central value of the parabola. And to find that, we are going to use the formula x is equal to minus b divided by 2a. From the quadratic equation, we get values of a, b and c as a is equal to 1, b is equal to minus 4 and c is equal to 2. This, when we substitute in the formula, we will get x is equal to minus of minus 4 divided by 2 into 1. Minus of minus 4 in the numerator will become 4 and 2 into 1 in the denominator becomes 2. And so we get 4 divided by 2 which is equal to 2. When we jot it down in the table, we shall keep this as the central value and we can assume 1, 0 and minus 1 in the left hand side and 3, 4 and 5 in the right hand side of 2. To plot a linear equation, it is not necessary to find all the points. Rather, we need to only find 2 points to draw a line. So we are going to find value of y for only the first and the last point. For x is equal to minus 1, we get y is equal to minus 8. And for x is equal to 5, we get y is equal to 4. For the quadratic equation, we get values of y as 8, 3, 0, minus 1, 0, 3 and 8. Now that we have all the coordinate points, let us plot the line and the parabola separately. Plot minus 1, 8 and 5, 4. Then join them by a straight line. This will be the line representing the linear equation y is equal to 2x minus 6. In the same way, plot minus 1, 8, 0, 3, 1, 0, 2, minus 1, 3, 0, 4, 3 and 5, 8. On connecting these points one after the other, we get a parabola. In this graph, we get the intersecting point to be 3, 0 and this point becomes the solution of the simultaneous equation. Here, the parabola and the line intersects at only one point and so this problem has only one solution. So in this video, we saw how to solve a system of linear and quadratic equation using graphical method. An assessment on this topic has been made and its link is given in the description box. Do give it a try. More examples on this topic will be covered in another video. If you have any queries on this topic, do mention it in the comment section. Did it help you? If so, share it with your family and friends. Did you like this video? If so, hit the thumbs up button. To get notified about the videos from time to time, do not forget to subscribe to Fun Maths Academy. Thank you.